Where I'd like to start is beginning from one of the slides from lecture 18 where we discussed the boundary layer. So just again looking at the main parameters, we have a sharp leading edge of a flat plate. There is a flow upstream that's assumed to be uniform with a uniform velocity and a uniform temperature. The flow comes in, splits top and bottom of the plate, and on the plate a boundary layer begins to form. I'm not showing the boundary layer forming on the bottom of the plate, but obviously there should be one. So what we have is this locus of points where the value of the velocity is going from 0 at the plate up to the free stream velocity. The distance along the plate is given by a parameter x, and at some point the boundary layer will transition from what we refer to as a laminar boundary layer to a more disordered boundary layer known as the turbulent boundary layer. This occurs at a specific point called x critical, and we'll assume that there is this magical transition from laminar to turbulent, which of course is not the case. There is a transition region where you're neither laminar nor turbulent. For a flat plate, the Reynolds number is defined as a monotomically increasing value as a function of x. So the assumption is that the free stream velocity is not changing, nor are the fluid properties, in this case the kinematic viscosity, or you can also write it in terms of density and the absolute viscosity. So for a plate of length L, we can sometimes refer to the Reynolds number for the entire plate, call it that this would be the maximum Reynolds number that you would have. I can just substitute in for x a defined L value. Now, the critical Reynolds number is the Reynolds number at which we will transition from laminar to turbulent. This value is really dependent upon the parameters that make up the plate and the free stream and the flow velocity. So if the plate is rough as compared to smooth, you might have a different transition from laminar to turbulent. Same thing with the amount of initial turbulence in the flow. So the fluid flow does not have to be considered completely turbulent, but there is always going to be slight eddies and microturbulences within the flow. So both of those can definitely influence the point at which the flow will go into transition from laminar to turbulent. But unless otherwise specified, the value that we will use for the critical Reynolds number is 5 times 10 to the 5th. Know where the critical Reynolds number is, or what that value is. You can then utilize that to define the position along the plate known as x critical, and that is the point where we will assume that the boundary layer will make this sudden jump from laminar to the turbulent boundary layer.